even and odd functions. Before to talk about the even and odd functions of Fourier series, let me generally talk about even and odd functions. What are even and odd functions here? If the function f of x equals to x, if I multiplied x by minus, it equals to minus x, which is not equals to f of x. My function is x here, but when I multiplied it by minus, it equals to minus x, which is something different, because my original function is plus x, not minus x. Therefore, it is odd function. So x is my odd function here. Similarly, if f of x equals to x cubed, and if I multiplied x by minus, it equals to minus x cubed, which is not equal to f of x. If I have a function x cubed, and if I multiply the variable x by minus and then take its cube, it equals to minus x cubed, which is not my original function, because my original function f of x equals to plus x cubed, not minus x cubed. So x cubed is an odd function here. So is x to the 5, x to the 7, and so on. If the power of the variable is in odd form, it is called odd function. But if the function f of x equals to x squared, and if I multiply the variable x by minus, it equals to plus x squared, which equals to f of x. My function is x squared. I multiplied the variable x by minus and then take its square. It equals to plus x squared, which equals to my original function plus x squared. Therefore, it is called even function. So x squared is even function here. Similarly, if f of x equals to x to the 4, and if I multiply the variable x by minus and then take its whole power 4, it equals to plus x to the 4, which equals to f of x, which is my original function. So x to the 4 is an even function. So is x to the 6, x to the 8, and so on. If the power of the variable is in even form, then the function is an even function. Now let me take a trigonometric function. If f of x equals to sine x, if I multiply the variable x by minus, it equals to minus sine x, which is not equal to f of x. My function is sine x here, and when I multiply the variable x by minus, which equals to minus sine x, which is not my original function, because my original function is plus sine x. So sine x is an odd function. Similarly, if I take a function f of x equals to sine 2x, if I multiply the variable x by minus, it equals to minus sine 2x, which is not equal to f of x. My function is sine 2x here, and if I multiply the variable x by minus, it equals to minus sine 2x, which is something different, because my original function f of x is plus sine 2x. Therefore, sine 2x is also an odd function, and so is sine 3x, sine 4x, and so on. These all are odd functions. But what if the function f of x equals to cos x? If I multiply the variable x by minus, according to the trigonometric rule, cos minus x equals to plus cos x, which equals to my original function f of x. I have a function cos x, and when I multiply the variable x by minus, it equals to plus cos x, which is my original function f of x. Therefore, it is even function. So cos x is even function here. Similarly, if f of x equals to cos 2x, and if I multiply the variable x by minus, it equals to plus cos 2x, which equals to my original function f of x. I multiplied the variable x by minus, where according to the rule it equals to cos 2x. So cos 2x is also an even function, and so is cos 3x, cos 4x, and so on. These all are even functions. Graphical representation of even and odd functions. Let me show you graphically how even and odd functions look like. Let me put x, y axis. This is my x-axis, here is y-axis. First I'm gonna take an even function which is x squared, and the graph of x squared is here. At origin 0, start from minus pi to plus pi. This is x squared. Let me take one more function here, which is cos 2x. This is the graph of cos 2x. At origin 0, its range is from minus pi to plus pi. So I have two even functions here, x squared and cos 2x. These are even functions y, because they are symmetric at y-axis. If you look to the graph of x squared, where the right side of the graph is equal to the left side of the graph, it is symmetric at y-axis, because whatever you have at the right side of the y, you have the same thing at the left side of the y. It's like y-axis is the mirror in the middle. You see the exact shape in the mirror. Similarly, in cos 2x function, where the right side equals to the left side. So whatever you have at the right side of the y-axis, you have the same thing at the left side of the y-axis. So again here it looks like that y-axis is a mirror in the middle. Now let me take an odd function here. At origin 0, which ranges from minus pi to plus pi. It is a function of x cubed. This graph is a function of x cubed. Let me take one more odd function here. At origin 0, which ranges from minus pi to plus pi. It is the graph of sine x. These are odd functions. Why? Because they are symmetric at origin. Remember, the even functions were symmetric at y-axis. Odd functions are symmetric at origin. Look to the x cubed function, where this side of the graph, which is in the first quadrant, equals to this side in lower quadrant. You see here it looks like that you adjust the mirror at the origin. It is symmetric at origin, not symmetric on y-axis. Similarly, look to the sine x, where this side equals to the lower side here. Again, when you see here, it looks like that you have mirror at the origin, not on the y-axis. So sine x is symmetric at origin. So these were the graphical representation of even and odd functions.